Okay, Lova. So let's proceed ahead with your technical snap for fluid mechanics, and you're going for DRDO, right?
Yes, sir.
Hmm. Okay, Lova, can you tell me what is this approaches, macroscopic and microscopic approaches to analyze the fluid mechanics problems?
Sir, microscopic approaches if you want to know whether the fluid is
Have you heard about
rotational or
Eulerian and Lagrangian approaches?
sir, Eulerian approach is so basically Eulerian approach is we are in that case in that process in that approach we are uh, se- focusing on a space at a particular time to find the properties of the fluid at a particular time. Whereas Lagrangian approach is used to know the path followed by the fluid particles.
Okay. So which one is microscopic? Which one is macroscopic?
Sir, Eulerian approach is microscopic, sir.
Okay.
Lagrangian is microscopic approach.
So can you give some example of Eulerian approach used in fluid mechanics?
Sir, by using Eulerian approach, we can find the whether the fluid is rotational or not. Uh, in that to find we can't say the fluid whether the
But how
fluid
do
is
you do? How
rotational
do
or
you
not.
implement Eulerian approach?
Uh, if you know the velocity profile of that particular fluid flow, from that we can find by using some mathematical analysis, we can say that whether the fluid is rotational or not. In that case, the fluid particles are rotating about the axis, but we can't say the fluid is rotational by using the naked eye. So that's why it is called microscopic analysis.
Hmm. No, but the Eulerian approach, may you go with the particular fluid element, huh?
Yes, sir.
So in this, are you going with fluid elements?
Yes, sir.
Okay, tell me the difference between path line, streamline, and streak line.
Okay. Sir, path line means the line which is followed by particular fluid element between the 2 points, between any 2 points that we have selected. Whereas the streamlines, when on a fluid flows or any other body, it follows some path. That path is called the streamline, sir. If your exhaust gas coming out from the cooling tower, if all is we can say that flow line is the streamline.
Okay, what do you understand by fluid kinematics?
Helps us to know how the fluid is flowing, like the fluid parameters, like from by using the fluid kinematics, we can know the velocity, acceleration of the fluid particles.
Okay, and how do you calculate acceleration of the fluid in x direction? Suppose I want to calculate the acceleration of the fluid in x direction.
Yes, sir.
What
Yes.
parameters are required for that?
Sir, is that one-dimensional flow or three-dimensional flow, sir?
Let's say one-dimensional flow. For one-dimensional flow, if I want to calculate acceleration in x direction, what information is required?
Sir, for that we need to know the velocity profile in the x direction, and yes, sir. If it is say velocity acceleration in the direction, sir.
So acceleration in x direction, does it depend upon velocity in y direction of the fluid?
Uh, sir, 1 minute, sir. Sir, I'm considering it as one-dimensional flows. That's why the velocity profile in the other two directions are zero. I assume that. So
Can you
that's why I
write the
said the
formula
only.
of acceleration in x direction?
Yes, sir.
There are local
For
and
acceleration,
convective.
acceleration is u into. Yes, sir. Yes,
Yeah.
sir. Local acceleration is u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z. That was the local acceleration, and sir, yes, sir. And
That is
that
local or convective?
was convectional acceleration, sir. And dou u by dou to the space, if it is changing, that is convective, and with respect to the time, if it is changing, that is local, sir.
Which one is local?
Local is LST. If the velocity is changing with respect to the time, then it is called local acceleration.
Which one is convective?
Hello.
Which one is convective?
Convective acceleration is that yes, sir. If the velocity is changing with respect to the space, when with respect to space, then acceleration. If it is uniform flow, the convective acceleration will be zero, and if it is steady flow, then dou u by dou t will be zero.
Okay. Now tell me why velocity in x direction depends upon dimensional change in y direction in case of fluid.
If we can assume the fluid is flowing through a pipe, if we increase the diameter of that pipe, then obviously the velocity profile is changes. So that's why it is indirectly, it directly depends upon the shape of the size, which is in y direction. That's why the in one-dimensional flow, the velocity is a function of y variable also, y axis also.
What do you understand by streamline?
What, sir?
What do you understand by
Can you repeat
streamline?
the question?
What do you understand by streamline?
Streamline, sir.
Streamline.
Okay, sir. Streamline is the yes, sir. So between any 2 points, if you take it as a particular between any 2 points, if you take a path followed by a particular point, then it is called streamline, sir.
And what is stream function?
Sir, can I say, sir?
Yeah.
The stream function which is used to know in any case, by using the stream function, we can know the direction of the fluid particle. Sir, for the streamline, if you draw at a particular point, if you draw a tangent to that curve, it denotes the velocity of that particle at that particular point. By using stream function, we can know the direction of the particle.
Have you heard about mixing length?
Yes, sir.
What do you understand by that?
Sir, mixing length is when a lump of fluid moves in vertical transfer direction. If you take a one-dimensional fluid element, some lump of fluid moves in vertical direction to make the momentum change in momentum remains the change in momentum equal to zero. To make the moment remains same, that transverse length is called the mixing length, sir, which is used to find the shear stresses.
Okay. Okay, Lova, let me give you the feedback. Lova, your level of fluid mechanics still needs to be improved.
Okay, sir.
So I want you to go through marathons again.
Yes, sir.
You have not gone through a marathon 3-4 times. Lagrangian, Eulerian, acceleration
Sir,
in x direction.
yes, sir.
Acceleration in x direction in fluid depends upon velocity in y direction also.
Okay.
B, W components are coming. Acceleration of the solid body in x direction only depends upon velocity in x direction. dv by dt. Right?
Okay.
So he will ask you those minute things.
Okay.
your level you have to improve, you have to revise more so that you are in position to give right answers, right?
Oh, okay,
So
sir.
go for it and revise that marathons again and again.
Okay, sir.
Got it, Lova? And go for some
Yes, sir.
more snaps.
Okay, sir.
Okay.